So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we are going to discuss a topic called as study of common geological structures. So we have already discussed about different types of rocks, their structures, their formation, and their ages also. If you remember in the previous lectures, we have just discussed about the ages of the rock, how much old they are, when they are formed, what is the formation process, and their geological time scale. That all we have already studied in the previous lectures. So let us understand today study of common geological structures. What are the common geological structures? Basically, when this formation will take place, what kind of structures are formed in the on the Earth's surface. So there is a strike and dip study of common geological structure. First of all, there are two types of strike and dip kind of geological structure, basically, which is very commonly seen in the bed of the rocks, or commonly seen in the what you can say the sedimentary rocks, and any kind of rocks we can see the we can see the strike and dip. So the study of strike and dip is fundamental in the structural geology. Structural geology, if we talk about in the previous lectures also, we have discussed about the structural geology. It is basically the study of the structure of the rocks. Okay, so strike and dip is a fundamental. It's a fundamental in the structural geology because it describes the orientation of rocks. Describes the orientation of rocks, layers of geological structures. These measurements provide crucial information for understanding the geometry and movement of the earth crust. Okay, so the measurements provide the crucial information. It gives you the crucial information for understanding the geometry of the movement of the earth crust. So by analyzing strike and dip, these are the two types of common structures which is found in the bedrocks. So geologists can determine how layers of rock have been deformed by the tectonic forces, how fold and faults are oriented, and how these structures affect the landscape. So analyzing the strike and dip, where the geologist can determine the layers and the rocks have been deformed by the tectonic forces, and how they fold, their faults are oriented, and how these structures and about the landscape. So let us understand what is strike. So strike and dip, as I said, it's a very common geological structure. So strike is a definition. If we see, strike refers to the compass direction of the horizontal line. Compass direction of the horizontal line formed by intersection of the rock layer, or any geological surface with a horizontal plane. So strike refers to the compass of direction and the horizontal the formed by the intersection of rock layers or any geological surface with a horizontal plane. We call it as strike. Horizontal plane, where there is a on the surface the line from here to here or here to here, we call it as horizontal plane. Now description, it's the direction of the line. It's the direction of the line, as we can see here, direction of the line formed where a bedding plane, fault plane, etc. intersects a horizontal surface. It's typically measured as an angle relative to north and expressed in the degrees. Okay, so this is the description of the strike. Basically, it's a horizontal plane, so on the surface you can see, and key point is strike tells us the orientation of the feature but not the steepness or tilt of the layer. So as it is a horizontal line, it doesn't tell us the tilt or the layer of the earth. So in this picture you can easily identify. Now here you have a strike like this. So this is the strike here. So it's a horizontal plane. This is the horizontal plane where you can see the line between this direction. This is the inclined the line which you can see here. So that we call it as strike. Okay. Now strike is a horizontal line, whereas when you talk about dip, what is a dip here? So dip refers to the angle. It's a angle at which a geological layer or structure is tilted related to the horizontal plane. Now if you see in the previous image, so this is the angle which you can see, this is the horizontal plane, and from here there is an angle beneath this angle we call it as dip. So down to the horizontal plane in a angle direction, that we call it as dip. Okay, so dip refers to the angle to which the geological layer or structure is tilted relative to the horizontal plane. Now it is measured at right angles, to the strike, with the dip direction being the direction which the rock layer is sloping. So always it's like a description of the dip, we call it as a right angles to the strike. So when you see the strike, it will be right angle to the dip, is the right angle to the strike. Okay, now the right angles preserved, which the dip direction being in the direction which the rock layers is sloping. So the dip angle is measured in the degrees. It is measured in the degrees from the horizontal, typically ranging from 0 degrees to 90 degrees. So horizontal plane is 0 degrees and 90 degrees vertical to the dip. So like this, usually it will be like this, or like this. Okay, so like this. So this will be your dip, and here this will be your strike. Okay, so this is the common geological structure which we see in the on the earth surface. So dip indicates the steepness and direction of the dip. It indicates the steepness and direction of the tilt. Together, strike and dip give a complete description. It will give a complete description of a geological structure orientation in three-dimensional space. So dip indicates the steepness, whereas in a direction of the tilt, together strike and dip give a complete description of the geological structure orientation in the three-dimensional shape. Now here we have a very easy diagram to find out about the strike. Now this is your horizontal plane, and on the horizontal plane you have a strike line. This is the strike line. So beneath this plane you have an angle which is going down, that we call it as dip on the earth surface, on the structure of the rock. So next thing what we can understand in this common geological structures are faults. This is the fault, and unconformities. Unconformities are both, they are the both geological features. They involve distribution of rock layers, but they arise from the different processes and represent different types of geological events. So as both geological features involve disruption of rock layers, but they arise from different processes, represent different types of geological events. Now faults, we have a fault is a fracture in the earth crust. It's a fracture in the earth crust along which displacement has occurred. So the fault is a, basically it's a, in the previous lectures also we have discussed about the fault line. So fault line is a fracture. It's a fracture in the earth crust along with the displacement has occurred. So this displacement can happen vertically. This displacement can happen vertically, horizontally, or obliquely. And the forces causing this movement can lead to the earthquakes. And fault can be classified into three main types. So they are basically classified into three main types based on the direction of the movement. Direction of the movements. Faults we classify as normal faults. Okay, in the previous lectures also we have discussed about the faults. So it is classified as a normal fault, reverse fault, strike, slip faults. Okay, so these three common fault we see on the earth surface, beneath the earth surface. This happens due to this tectonic activities acting on the earth surface or beneath the earth surface, right? Now we have a normal fault here which occurs when the hanging wall moves down. Hanging wall moves down relative to the footwall, typically due to the extensional forces. So here you can see here in the, when you talk about this normal fault, so this is about the normal fault. And so this is the main, you can see here, this is the main surface. Okay, so part of the land. From this there is a fracture here. Okay, we call it as fracture. So this fracture is basically a fault. Fault is basically a fracture in the earth surface. Now this wall This is the wall. We call it as hanging wall. Okay, hanging wall. When it is sliding down, okay, it's sliding downside. Sliding downside. There is a crack between this wall and this wall. So due to this earthquake, or you can say that due to this plate tectonic activities, now this the hanging wall has moved down. So these rocks drop down relative to rocks across the fault. So this is the across the faults, they drop down. So this kind of fault we call it as normal fault, where from the main surface the partition, or due to this tectonic activities, the hanging wall comes down. So that we call it as normal fault. Then we have a reverse or thrust faults. Reverse faults or thrust faults. So occur when the hanging wall moves up. Now let us see here, moves up to the footwall, typically due to the compression forces. Now in a normal fault the hanging wall comes down, right? Comes down. Whereas in the reverse fault, same, this is the same hanging wall here, so it goes up. Okay, so this is your main, you can say surface, main surface, or main part of land, part of, okay, so main part of land, right? From this land, this hanging wall, which has been already due to the fault conditions or due to this tectonic activities, there is a fracture between these two earth. Okay, the fracture between these two types of land. So these two type of land, this is the hanging wall. Instead going down, instead moving down, it will move up direction. So it moves on the up direction. So that we call it as reverse fault. Okay, reverse fault. So these rocks raise up relative to the rock across the fault. So that we call it as reverse fault. Okay, now we have a third type of what you can say here is third type of fault here. So in this involves horizontal movement. It involves a horizontal movement where the movement is parallel. The movement is parallel to the fault plane caused by the shear forces. Now strike a slip means here the movement what we can see here is it is horizontal like this. So this rock slides laterally relative to the rocks across the fault. So this is the part of land, first part. Okay, this is the second part. So in this you can see it is sliding from here to here, right? Sliding from here to here in a horizontal direction. So this is what the type of fault looks like in a direction it moves sliding apart, that we call it as strike slip faults. Okay, strike slip faults means here you have the strike line. Okay, this is the strike line basically. Strike line. So it is just crossing the strike line and just it is moving, that we call it as strike slip fault. Now we have unconformities. Unconformity is what when unconformity represents a gap. It represents a gap in the geological record. In the geological record where rock layers have been eroded. Rock layers have been eroded or where no deposition occurred for a significant period of time. So an unconformity, it represents a gap in the geological record, where rock layers have been, so the previous rock layers, it has been eroded or where no deposition occurred for a significant period of time. So suppose the weathering process is very common, okay, very common with all types of rock. But what happened, sometimes the layers have been eroded, and there is no deposition. So once it is eroded, if there is no deposition occurred for a significant period of time, that we call it as unconformity. So there is a gap between the erosion as well as the deposition of the sediments again back to the rock surface. So it reflects the discontinuity in the sedimentary record, and can be caused by variety of factors. It can be caused by variety of factors such as erosion, tectonic uplift, or changes in the sea level. Now, there are several types of unconformities here. So, as for the several types of unconformities, the angular unconformity, the disconformity, the non-conformity, we have different types of conformity here. So, when it occurs, the angular unconformity occurs when younger horizontally layered rocks lie on the top of older tilted or folded rocks. So it lies on the top of the older or tilted or the folded rocks. So that we call it as angular unconformity. Now we have a disconformity. Disconformity occurs when there is a gap in the deposition. There is a gap in the deposition of layers, but the layers on the other side are parallel. Layers on the other side are parallel. Now we have a non-conformity occurs when sedimentary rocks lie on the top of the older metamorphic rocks. So there is a layer of rocks, the bed of rocks where the sedimentary rock lie on the top of the older metamorphic or igneous rock, then we call it as non-conformity. So types of unconformities here: disconformity, angular unconformity, non-angular, non-unconformity. So unconformity is a regional extent, may change from one type to another. This may not represent the same amount of geological time everywhere. Now, in summary, while faults involve physical movement, displacement of rocks, layers, unconformities represents a gap. It represents a gap or discontinuity in the stratigraphic record. So both are important in understanding the geological history of an area and can provide insights, past tectonic activities, and the environmental conditions. Now coming to joints. So this common structure here in this topic, we have a common structure, we call it as joints also. So in geology, joints are fractures. They are fractures or cracks in rocks. Fractures and cracks in rocks occur without significant displacement of the rock on either side. So they are common in both sedimentary igneous rocks and result from stress that causes rock to fracture. Okay, so joints are basically it's a fractures. They are the or cracks in the rock, and they occur without the significant displacement of the rock on the other side. They are common in both sedimentary and the igneous rocks and result from the stress that causes the rock to a fracture. Joints are different forms faults because there is no displacement along the fracture. So basically, the joints are different forms. They are different from faults because there is a no displacement along the fracture. Joints can be classified into several types of based on their orientation and the stress causes them. Now, what are the common types of joints if we see here? So we have a common types of joints in this. We have a systematic joint. In a systematic joint, we have systematic joints. We have vertical joints, horizontal joints, oblique joints. So these are the set of parallel joints from under uniform stress, and they are usually seen as a multiple regularly spaced fractures that form and in the patterns. And systematic joints can be they can be vertical joints. They are perpendicular to the surface. They are having horizontal joints parallel to the ground or the strata, and we have oblique joints at the angle between horizontal and vertical. So that we call it as oblique joints. Now here in this picture you can see there are systematic joints here. Okay, these are the systematic joints. Then you have the systematic joints again, and these are the non-systematic joints. Okay, non-systematic joints here. Now, what is non-systematic joints here? So these do not follow any regular and may be randomly distributed. So they don't follow the regular pattern here. So they don't follow the regular pattern here, and they can be randomly distributed. Or non-systematic joints form under the irregular stress conditions or in an area where multiple factors affect the rock at the different times. Okay, so now we have a columnar joints formed by the result of cooling the contraction of volcanic rocks like basalt. They create the large polygonal columns that often appear in the hexagonal pattern, such as those seen in the places like Giant Causeway in the Northern Ireland. Now we have the other types of joint here is shear joint. Shear joint is what? So here we have a shear joint developed from the shear stress that causes one side of the rock to move relative to other. So these joints often appear in the association with the fault zones, but typically have no significant displacements themselves here. So shear joints are the joints basically develops with the shear stress, okay, and one side of the rock to move the relative to the other. Tension joints we have here. These joints form when the rocks are subjected to tensile stress, which pulls them apart. They often appear in the regions where the earth crust is being stretched, such as rift zones. And tension joints typically have no movement. They don't have any movement along with the fractures and just a separation. Now, compression joints. These joints occur due to the compressive stress, which focuses rocks together, causes the fractures. So they tend to form in a area where tectonic forces are pushing rocks towards each other. Such an is called as mountain building zones. Then we have a cooling joints. Cooling joints is commonly found in the igneous rocks like basalts or granite. These joints form a result of cooling and contraction of the molten rock. They typically form a hexagonal polygonal pattern. In the basalt columns. These joints are often quite regular in the shape. Rifting joints form in regions where the earth crust is being stretched, such as in the continued rift zones. Rifting joints often result in large vertical cracks. Then we have radial joints. These are the joints that radiate outward from the central point, which will radiate outward like this. So this will be the central point. From here, the joints will be radiated like this. So this outward from the central point for often observed around the features like volcanic domes, wherever you find this volcanic domes or the intrusive igneous bodies. So they can form when the outer parts of the rock body are subject to tensile stress. Okay, so these are the common structures we have gone through. Like we have a strike, dip, fault, unconformities. Okay, so you can just go through these references again to find out the more content about this topic, like Keshav Luchenna or Venkat Reddy or Vasudev Keniti, Bibel, Fundamentals of Engineering, Gokhale. So these are all the references which you can go through to find out more content about the topic and more information about the topic. So that's all for today. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.